Ashish and I are from the Avi Networks team. How many of you were familiar with Avi Networks, what we did? Great, thank you. So we got acquired into VMware over the summer last year, and we're now part of the networking and security business unit within VMware. What I want to do is just offer you guys a quick intro and discuss the architecture, and then I'll pass it on to Ashish to give you guys a quick overview of how we integrate into the VMware ecosystems, as well as do a demo of our load balancing and WAF. So Avi got its start back in about 2012. We have sold into some of the largest enterprises, financial services, tech, media companies. I like to say, if you have ever transacted online payments, bought a movie ticket or a concert ticket online, or done online banking, chances are that your transaction went through Avi. So we have a lot of customers, including Adobe and Deutsche Bank and companies like that, that use our product for a variety of different use cases. So I'll just set this up. I mean, not that this information is new to you guys, but one of the ways that we explain to our prospects and customers what really Avi is looking to solve is this problem of the time to market and the modernization of the application infrastructure and the cost efficiencies that enterprises are trying to drive. And Avi is basically, it was born to solve this problem of increased demands of the IT folks to deploy new applications, deal with the application velocity and the changes, as well as the multi-cloud nature of most enterprises today. So if you look at the picture here on the right, a few years ago, we spoke to a customer in the East Coast, a large financial institution, that talked about how cool it was that they could develop a VM vending machine experience for their developers and provide a self-service portal for when they needed a computing resource. And what they found out very quickly was, once they did that, they'd have to hurry up and wait for the load balancer to be provisioned, because that was the piece that wasn't quite automated. They would have to procure appliances or stand up a new piece of infrastructure to add a new VIP to provision that application for production. So this was a common problem that we heard from most enterprises. So the further challenges in terms of the hardware load balancers themselves is, most of the time, whether you're dealing with a specific appliance-based load balancer and hardware, or a virtual machine-based virtual load balancer, the architecture is the same. So you deploy an active standby pair of appliances. And when we speak with customers, the average utilization of these appliances at any given time is at about somewhere between 15 to 20%. And the standby appliance, of course, is not used until there is a disaster scenario. And this sort of active standby pair is stamped out throughout the infrastructure across the data centers that they own. And the challenge, of course, with this is that while you have all of this fungible capacity, you can't really use it. And it's a major problem, because you have to manually place the virtual machine in each one of these appliances. When you have a new virtual service that you want to build, you have to know exactly which appliance you're going to place it on, what capacity that appliance has, and if it ever reaches capacity, it's not like you can use the spare capacity that is available. And in fact, one of our customers best described this as, he knows all of his load balancers by name. Right? He knows that Jim has spare capacity, Sally there has an upgrade coming up, and so on. He was joking in a way that saying that this is why there are pets. And this model of pets versus cattle sort of plays itself out with every one of our customers. The other, of course, challenge is that every single pair is administered individually, and you have to go in and adjust policies for each one of them. There's no centralized way for you to handle that, and that's an operational complexity for a lot of enterprises. And the last piece here is that these load balancers are quite not designed for the modern infrastructure, right? Across multiple clouds, across containers and microservices type applications, et cetera. And then if you look at challenges that happen with load balancing in the public cloud, you have a lot of the traditional automation challenges that you have with existing hardware load balancers addressed. But with AWS and in Azure, there are sort of issues around feature completeness and performance of these load balancers. You have to stitch together a bunch of different tools for DNS, for web application firewalling capabilities and logging and analytics and so on. And each of them is a siloed load balancing solution for that cloud. If you need something that is consistent across multiple cloud environments, you don't really have a way to do that. And then, of course, the last point here is that a lot of the traditional vendors have come up and said, if you want to take your load balancer to the cloud, you have the option to take a virtual load balancer and put it in AWS. And that works out, as we all know, it's too expensive. It suffers the same sort of scalability challenges as well as the architectural limitations. So how do we solve for this? What is required to happen in order to solve for these challenges? My clicker is a little sensitive. Okay, so on the first thing that the Avi team did was they set out to essentially create an SDN-like architecture for load balancing. And the first thing that they did was separate the control plane for application delivery from the data plane itself. So you have service engines, which are essentially the load balancers, and a central controller that addresses the entire life cycle of the data plane. So the data plane itself is a very elastic fabric that can grow and shrink. So you can spin up additional load balancers or reduce the number of load balancers that you're dealing with. And the load balancers themselves can be deployed across on-prem environments as well as any public cloud. In bare metal environments, so you could, if a customer is most comfortable with using a Dell server and putting a load balancer on it and consuming it as an appliance, they can do that. Or they can put it in a virtualized infrastructure or a Kubernetes-based container environment as well for ingress and load balancing services there. One of the other unique insights that the Avi founding team had was when we have a distributed fabric like this for load balancing, you can essentially use the load balancers. They're sitting in such a privileged location in the network, being able to collect all of that application traffic intelligence that is going through them. And so the service engines themselves provide telemetry in real time to the controller. And we actually are able to use about 600 odd metrics that allows us to provide all kinds of application intelligence that Ashish will share with you in the demo section. And so, and the last piece here is the automation itself. Because we have this controller architecture, we have cloud connectors to a variety of different ecosystems. And so we can very quickly automate the entire infrastructure to deliver self-service to application developers. So this architectural difference is what allows Avi to essentially provide the same consistent load balancing services or web application firewalling services across different environments. So let's take a look at what it takes to go from that monolithic single cloud appliance. And with this architecture, what we're able to do is deliver a application services fabric that consists of a software load balancer, a web application firewall, or a container-based ingress service for Kubernetes clusters and so on with Avi. So this is the architecture. This is the components of the platform. What I want Ashish to do is walk you through the rest of the deck here and how we fit into the VMware ecosystem, as well as the demo.
So thanks, Chandra. So Chandra gave you a brief introduction to the architecture, right? So let me take you to next into how we fit into different ecosystems and the features and the use cases. So it's the same solution that runs in any environment. It runs in a VMware environment, it runs in a public cloud environment, and it provides a set of services from load balancing, GSLB, web application firewall, DDoS detection mitigation, application analytics across any cloud. And as VMware, we are doing deep integrations with various VMware product portfolios. So the same product runs in any cloud, but also within VMware product portfolio, we're doing deep integrations with NSX, with VCF, with the EUC, the Horizon and Workspace ONE portfolio, with Tanzu, with the container services and so on. So this, again, it's a universal multi-cloud, multi-services solution. And when we talk about features, The left side of the screen talks about the features that you expect from a typical load balancer or ADC, as you call it, product. Local load balancing, layer 4, layer 7, GSLB, content switching, caching, compression, auto scaling. You will not find them in the other appliances. Why? It's a controller-based architecture. Security for full WAF stack, SSL, TLS, DDoS, your full policies from layer 4 to layer 7, client authentication, SSO. It's a full stack ADC. On the right-hand side, you'll find something that it's not in any of the other solutions. It is full application infrastructure analytics. And instead of talking about it, I'll show you in a demo. As well as a full centralized management. And let me pause here and talk about central manager versus central controller. A lot of companies talk about, oh, we have a central manager. Well, where does the policy reside? Where is the intelligence? Can I manage each appliance individually? If the answer is yes, that's not a controller. That's just a manager, right? Avi is a controller, which means that's the only way to talk to the product. You cannot manage individual service engines, right? The policy stays as a single place. It's a fully multi-tenant solution, full RBAC. So you can do complete isolation of tenants and users, and everybody can manage only their set of load balancers and not step on anybody else. It is, of course, APIs. That's a given, but we have on top of that, we have Ansible, Terraform, VRA, VRO, full SDKs, all of that out of the box. So the Swagger spec, we'll talk about that. And you have built-in IPAM and DNS as well. And it's the same solution that also works across multiple use cases. Same bits, same feature set, same API. You can use them on-prem. You can run in any native public cloud instead of ELB or App Gateway and so on, as well as VMC on AWS, and in any Kubernetes environment. Again, same bits, same feature set. One of our customers called it polyglot. We take the form of the underlying infrastructure. You deploy in Kubernetes, you deploy as a container. You are in public cloud, you deploy as an AMI or a VHD, depending on the cloud, right? It's software, it's not an appliance. That's a key difference. With that, let's switch gears a little bit and talk about security, and specifically WAF. When we talk to customers, they say WAF is important. Application attacks are increasing. We have to protect applications at the top layer, including WAF. But 90% of those are not deployed today. Why? Because it's extremely complex, right? So when we built WAF in our product portfolio, we made sure, first of all, it's not a point solution. It's part of a feature suite, a full security feature suite, from layer 3, layer 4 rules to SSL TLS, to user authentication, to layer 7 rules, application rate limiting, and on top of that is WAF. So it's a full stack of security features, all integrated with centralized policy and centralized intelligence. We'll talk about that. And specifically around WAF, the way we address these challenges were tied to the architecture, right? So the 3 common issues that our customers told us were, it's complex. We are worried about turning on WAF, because what if we made a mistake? And if it does, something is blocked. We have no idea why the traffic was dropped. Why? Because it's opaque. There is not enough visibility. And finally, one of our customers told us that during the peak traffic, we turn off WAF. Why? Oh, because it'll kill our load balancers. Because every time you enable WAF, it is very heavy CPU utilization that the WAF requires. And if you have an appliance that Chandra talked about, where you have capped by a box capacity, if you enable WAF, you cannot serve the traffic. The way we addressed that was, again, centralized controller, so centralized policy management with full automatic learning model in our WAF. So it simplifies your policies, rich visibility and analytics. And again, I promised you I'll show you. And third, scale out architecture. As the traffic grows, you add capacity. Imagine you're deploying applications in AWS. You don't tell AWS, oh, deploy a 1 gig load balancer. You don't do that. You don't say, spin up a VM of this instance size. No, you say, you call an API, spin up an ELB. As the traffic grows, the ELB automatically scales out. Applications scale out. Well, we give the same performance, same experience on-prem or in public cloud, right? That's the beauty. It's a cloud-native solution, regardless of where you're running. Specifically around WAF, and so those benefits go in around WAF as well. And so specifically around WAF, we have a 3-stage WAF pipeline. When the traffic comes in, it first hits the whitelist engine. And the job of the whitelist is, this is where the customers have said, I know that this is what I know my application URLs or my IP addresses are known, well known. Just let them go through. These are all well-known traffic patterns. So that hits the whitelist. The most interesting stage, and the most important stage, is the positive security model. This is where the system is auto-learning. Okay, this application has these patterns. The URL looks like these. It has these fields which are alphanumeric only, and so on. As the system learns, it automatically allows that traffic to go through quickly at a high performance. And the rest of the traffic then goes through the signature engine, where we provide both a default rule sets, which with the streaming rules from our web portal, as well as your customers can create the custom signatures as well. So this is the negative security model. So it's a 3-stage pipeline. And as the system learns, the amount of traffic that hits the signatures is minimized, resulting in higher performance. Okay? This, let me pause here. This was the end of the slides portion of it. Any questions before I go to the demo?
What's the next piece? You got the load balancer.
Yes.
The web application firewall.
Yes.
It went up right up the rack. There's nothing left.
Well, no, yeah, there are a set of layer 4 to layer 7 services. So as part of the VMware portfolio, we'll integrate with NSX Intelligence. I think that Ray was just talking about. Then there are other layer 4 to layer 7 services. We talk about API gateway, talk about anything that you do at the application level, right? So we have plans to go into basically up the stack.
That's what it looks like. Yeah.
The signatures.
Yes.
How are you writing the signatures? Is it like an IPS model signatures, or are you doing something else?
So these are WAF signatures. So the system comes with the default OWASP top 10 protection, so core rule set 3, CRS 3.0. But we also have streaming signatures. So we have a SaaS portal from which you can stream the signatures directly. So as the new signatures become available, they get streamed down to the controller. Customers can write their own signatures as well.
And you have documentation and guidance on writing the signatures?
Yes, yeah. We support, we have a full documentation, yeah. We have customers who are running this in production for a few years now, yeah.
Very cool.